Good afternoon, everybody. We'll be starting in just a couple minutes. So grab a coffee and we'll get going in about 2 minutes. Let some more people get connected. Hi, everybody. It's 1 p.m. We're going to get started in just a couple minutes. Let a few more folks get connected. Okay. Good afternoon, everybody. It's just a couple minutes after 1. We are going to jump into the content. So before starting, I want to say thank you very much for everybody attending today. I know a Friday afternoon webinar can sometimes be challenging, so I appreciate the time, taking the time out of your busy day to join us on at least where I am is a pretty great July afternoon. So in this webinar, we are going to discuss a few, not all, but a few of the strategies that you could use in order to host a website on the Amazon Web Services platform. So just a very quick introduction before we jump into the actual agenda and the content for today. My name is Brett Gillett. I'm the founder and the chief orbiter of an organization called Curious Orbit Cloud Consulting. We are a consulting company based in Oakville, Ontario, and we are solely focused on Amazon Web Services. So we provide accelerator programs for both customers as well as AWS partners. We provide training, professional services, and managed services. I've been using AWS for quite a long time now, about 10 years, lots of hands-on technical experience running my own businesses on the Amazon platform, as well as helping several large Canadian enterprise companies leverage Amazon for their infrastructure. Most recently, I helped a large North American VAR build out their Amazon Web Services business. So I spent the last couple of years doing that. Curious Orbit started in January, and like I mentioned, focused primarily on professional managed services as well as training for both customers as well as AWS partners. Lots of technical hands-on experience. Up until very recently, I was able to say that I held all certifications that Amazon had in market. Recently, they've released a couple specialty certifications. So I hold 5 of 7 certifications and lots of hands-on experience. So we're going to jump into content. Here's the agenda for this afternoon. We're just going to talk very briefly about why you should consider Amazon Web Services as your cloud service provider, not only for hosting websites, but just generally for building out solutions. We're also going to talk about briefly just some best practices. Again, we're going to look at the context today around hosting websites on the Amazon platform. But remember, many of these best practices would apply to non-web workloads, so infrastructure that we're just building on the platform. And then we're going to look at 3 unique use cases or deployment strategies today. We are going to look at running a static website on AWS using the simple storage service S3. We are going to discuss running a multi-availability zone deployment for your website. And then finally, how could we potentially, at least in one way, leverage different serverless solutions on the Amazon platform to host our website. Now, I know there are many other ways to deploy and host websites on the Amazon platform, things like Elastic Beanstalk, but these are the 3 use cases that we're going to focus on for today's webinar. So first, let's talk about why Amazon Web Services. First and foremost, when we're thinking about particularly hosting websites, it is quite easy to get started. And we're going to show in the next couple slides here reference architectures that I think demonstrate the overall ease of using the platform to stand up a website very, very quickly. It's also quite cost effective. So it's a utility-based computing platform, which means in the majority of cases, not all, it's going to depend on the service, but in the majority of the cases, we have access to utility-based pricing. So we're only paying for the infrastructure that is running at that moment in time. We're only paying for the infrastructure that we've deployed. So we're able to, in a very cost-effective manner, get started on the Amazon platform. And as the web application that we're deploying or the website that we're deploying grows over time, we can scale up the environment and adjust that based on actual requirements. So that kind of leads into the next point. Start very, very simply, manage your costs, have an opportunity to build out the platform, work out any sort of kinks, and then scale that environment based on actual demand. All of the solutions that we're going to look at today are also deployed in a way that's highly available. So that means if we have a problem in our application code, the application components that make up our website should be able to survive that failure and be able still to deliver customers content to customers. Also, if there is something that happens on the Amazon platform itself, if there's an outage in an availability zone, the architectures that we're going to go through here in this webinar are built in such a way to be highly available. What's interesting about the 3 reference architectures that we're going to look at today is they're highly available, but in different ways, and the fact that 2 of the 3 reference architectures are inherently HA. We don't have to think about the high availability design and the management of that infrastructure. It's built into the services. The third the third option that we have, you can see the amount of additional administration, but we're still able to deploy a highly available website on the Amazon platform. So before having a look at our reference architectures, let's go through some best practices that you need to keep in mind when you are building out infrastructure, not necessarily only web infrastructure, but applications just generally. As you're deploying those on the platform, what do you need to be aware of? First, at every opportunity that we have, we should be caching data. And it's important for a couple reasons. First, it improves customer experience. So when we're able to cache data using a service like CloudFront, we're able to push our content out across AWS's global edge location network and be able to improve the latency associated with the delivery of application content from our websites or other solutions that we're building. We should also be thinking about opportunities to cache within our application. So instead of having our application or our web servers have to talk to the database every single time, is there an opportunity to layer caching in? So every opportunity we get, we should cache our infrastructure. It's going to improve customer experience and potentially, depending on the services, help us deploy smaller infrastructure or lower the number of requests to our back-end infrastructure, which should help us optimize for cost. Another thing to keep in mind, and many customers that I work with overlook the importance of this best practice. Just because we're running our infrastructure on the Amazon platform does not mean that we don't have to think about architecting our solutions for failure, whether that's failures in the Amazon platform itself or failures that we introduce during infrastructure changes or application updates. So we need to continuously, work on ways to build our solutions that are highly available. They're scaled across at least 2 availability zones. Most likely 2 availability zones will make the most sense for the majority of customers, but also in certain cases, if we have mission critical applications, do those applications need to be deployed in a multi-region deployment? And we're going to have a look at a couple examples in the reference architectures where, if required, you could relatively easily extend the reference architecture to another region. I think one of the most powerful things that you have access to on the Amazon platform is this idea of layers of security. So it's very important to remember that outside of designing for failures, depending again on the services that we're using, infrastructure as a service, platform as a service, serverless solutions, we have to think about who's responsible for the security. I would highly recommend to anybody on the call today that they spend some time and have a look at the AWS shared responsibility model. It's going to define who's responsible for what. Generally, AWS is responsible for the security of the cloud, and as customers of AWS, we're responsible for security in the cloud. So when I think about security at multiple levels, it really starts at IAM, or Infrastructure and Access Management, IAM. We need to start there and think about least privilege, IAM policies that we have to deploy in order to protect the resources that we are creating, limit access to those resources and the actions they can perform. Also, we have to think about, in certain cases, services like the Simple Storage Service, S3, have additional layers, resource policies. For our solutions, should we be layering on top of IAM resource policies as well to better protect what we're building? So what you need to do is, when you're solutioning these websites or applications on the Amazon platform, think about how we can attach or augment our overall security at multiple levels throughout the solution that we're building. Also, it's super important when we're thinking about particularly web infrastructure, but really all solutions. In most cases, we're going to build a solution that should be stateless. We're going to talk about scaling when we get into the reference architectures, but you need to be able to have applications that are running, let's say, on an EC2 instance. If you're going for a traditional infrastructure as a service deployment, we need those applications to potentially, access other services in AWS, maybe objects that are stored in an S3 bucket, or a queuing service like Simple Queue Service as an example. What we want to avoid is a situation where we are hard coding credentials within our applications or within our scripts that we're using to support the solutions that we've built on the platform. The way that we do that is to use IAM roles. IAM roles allow us to provide temporary access to the solutions that are running on the AWS platform, so scripts, applications, etc., temporary access to other services without having to create and manage static credentials. So a very important thing that in some cases is overlooked. So make sure that when you're thinking about building out these solutions, that you have a plan for how are you going to design your roles. And just like IAM users, we're going to need to think about the policies that we're going to assign to those roles in order to practice this idea of least privilege. Only give our applications enough access to perform actions or interact with other services in order to deliver the solution, and no more. The final thing is, how do we build stateless infrastructure? So if you're migrating existing applications to Amazon, this might not be something that you can do right away if you're doing a lift and shift. But if we're building some greenfield application, then we need to think from the very beginning, how do we get state information? How do we get static content? Things like that. When we're thinking about our websites, how do we get it off of the EC2 instances if we're using an infrastructure as a service deployment methodology in order to horizontally scale our application. What we want to be able to do is deliver just enough infrastructure or just enough horsepower in order to meet or deliver the best customer experience that we can. And as the demands on our infrastructure, our solution increase or decrease, then our application is able to horizontally scale. Add more infrastructure, you'll hear this as scale out, or remove infrastructure, scale in. It's not necessarily something that a lot of people think about, so we're going to show some examples of how to do that as we get into our reference architectures. Speaking of a reference architecture, here is a very simple deployment methodology that you might use if you have a static website. So I think it's very important to point out here, when we say static website, remember, there is no web server here. There's no Apache server, there's no IIS server. So really, we can't do any server-side processing, right? And in this case, you can see several services that are used. The first thing is Route 53. Route 53 is Amazon's managed DNS service, highly scalable. It's a global service. It allows us to, again, help lower the latency associated with, in this case, talking to our website by using the global network of edge locations that Amazon has built and be able to return query information to customers at the lowest latency possible. So let's, in this example, we've got our customers and they are trying to access our domain, our website at example.com. So Route 53 is going to resolve that information for them and pass it back to them. The next layer of this solution is CloudFront. CloudFront is Amazon's content delivery network. Again, possibly, depending on the distribution that you create, you can leverage the entire global edge location infrastructure. Now, we can use subsets of that infrastructure depending on our application, but you might be able to do a global deployment if required. So what CloudFront is going to do is cache our website for us as close to our customers as possible. So if this customer is accessing very frequently accessed data, then instead of having to go to our origin, in this case, our S3, our simple storage service bucket, CloudFront is able to return that request and avoid making the request to the origin, in this case, the S3 service. So this is going to improve latency, and it's also going to help us reduce our cost, which I'll come back to in a minute. And then finally, the last component here is an S3 bucket. So S3 is object-based storage in Amazon, highly cost-effective, highly durable, starts at less than 3 cents per gig per month, depending on the region that you're in, and it gives you 11 nines of durability. So what happens is when we create an S3 bucket, it is associated with a region, and objects that are stored within that bucket as part of the service are automatically replicated across multiple devices in multiple availability zones. This is the standard storage option. There are other storage classes available, but we're just going to talk about standard. So that allows us to get 11 nines of durability for, in this case, the resources that we're going to use in order to deliver our website. So if we look down the right-hand column here, we can see some highlights on the deployment methodology that we have here for hosting your website in an S3 bucket. It's extremely simple to get started. Once you've created your S3 bucket, you have to do some additional configuration to tell S3 to host a static website, define your index page, define your HTML or your error page, and then start moving your data into the S3 bucket. Once you've done that, you can start layering in the additional services. So creating a CloudFront distribution to cache your information, and then ultimately connecting with Route 53 for domain resolution. So quite easy to get going. I mentioned already, highly durable solution here because of the nature of the S3 product and its replicating of objects that are stored within the buckets that we create. Another, I think, a fantastic feature associated with this solution is there's no operating systems to manage. We're going to see another example of this later on, but the less operating systems we have to manage means less administration overhead. So I'm not managing the operating system, I'm not managing applications. All of that is handled on my behalf by Amazon. And finally, if we think here across these different these different reference architectures that we're going to look at today, this is the most cost effective. Very easy to get started, and you can host a very simple website at very low cost. The one thing that is important to keep in mind is it is meant purely for static websites. So you have no server-side processing in this deployment. Very simple strategy. Our second reference architecture today is, I would say, more common. I work with many customers deploying this type of infrastructure. Now, if you're looking at the diagram and you're familiar with AWS, you may look at the diagram and say that it's not complete, and that's correct. The reason that we did that was just to help keep the complexity of the reference architecture diagram down a little bit. We're not showing things like security groups. We're not showing things like subnets within the virtual private cloud. It's meant more just to illustrate the point. So what we've done here is you can see the top piece of this diagram looks very similar, looks identical, sorry, to the previous reference architecture. We're using Route 53 for managed DNS. We are still caching, in this case, the entire website using CloudFront. We'll come back to the caching in a minute. Below the CloudFront distribution is where things are going to start to change. This is an infrastructure, a mix of an infrastructure and platform deployment. So we have created a virtual private cloud, or a VPC, to isolate or create an isolated network within Amazon where we'll deploy all of our infrastructure. You can see in here what we've got is a multi-tiered deployment. This could be more than 2 tiers, but again, to keep the reference architecture relatively simple, we've just shown 2 tiers. So we've got a web tier, and then we've got our database tier, our back end. What we've done is fronted the entire infrastructure with the load balancer. In this case, we're using the application load balancer, but the classic load balancer still exists. So it's going to depend on exactly what you are attempting to solve here, but just know that you have multiple options. And the load balancer is an important piece here. Remember, thinking back to this idea of building a highly available infrastructure. The load balancer, managed service, nothing for us to manage on a day-to-day basis. It basically is going to evenly distribute requests across, in this example, our web servers. And when we combine those web servers combine the load balancer with the auto-scaling service, which will allow us to meet another best practice, this idea of horizontally scaling, we're able to scale out, add more infrastructure, or scale in, remove infrastructure as the demands on our application, on our website, change throughout a day, just a time measure. So the load balancer is connected to the auto-scaling group, and they are able to work together in order to scale out and scale in. You can see when we look at the load balancer layer, we still have S3. And we were talking earlier on about this idea of building stateless applications. It's much easier to scale an application when we get static content off of, in this case, our web servers. As auto-scaling is adding more infrastructure, we don't want to have to manage all of the static content on host. So S3 is still in the mix here in the fact that we can offload all the static content, CSS files, JPEG files, HTML files, depending on your application. And then when a new web server comes to life, the application is able to reference that S3 bucket instead of having content stored locally. This actually gets more important if you have a website where you are accepting user-generated content. It becomes even more challenging in a load-balanced environment. How do I get content off of one server onto another one? So you really should be thinking about how do you build stateless environments. Another thing that we've done with CloudFront, you can see CloudFront is directing traffic both to static content in S3 as well as our load balancer. So in this case, we have 2 origins, and we're using URL patterns in CloudFront to help CloudFront determine static content versus dynamic content. So when the requests are made by our end users, CloudFront will use the URL patterns to determine where it needs to direct those requests to. Let's just say, as an example, the JPEG request is fulfilled by the S3 bucket if it's not already cached. The dynamic content associated with the page that customer is is referencing would flow down through the load balancer, and the web server application layer would return that content. In the back end, we have a multi-AZ RDS deployment. Just one comment on RDS. It's important to note first off that you do not need to use RDS in this solution. I prefer to use RDS if possible because it offloads a lot of administrative work to Amazon. We get replication built in from our master to our standby. We get backups. We get updates, minor version updates. All of this functionality is things that we would have to do if we deployed an unmanaged solution. So if we had another EC2 instance with our database installed on top of it. So if possible, I highly recommend using platform services. And in this case, using an RDS database in the back end of your application allows us to offload a lot of work to Amazon. The one thing that I would say here is be very careful when you're thinking about RDS and make sure you understand the limitations around the service itself. So always have a look at the documentation and ensure that your requirements don't surpass a hard limit in RDS. So do that homework before deploying. So again, if we look at the summary of this reference architecture, it's highly available. It's built across multiple availability zones within a single region. So in the event of a problem at the AZ level, or we have to bring a server down for application or maintenance, the application or the requests will still be fulfilled because they can go to another availability zone. If required, we could push a solution that looks very similar to this across multiple regions. We could use Route 53. Route 53 has advanced routing technology. We could use health checks. We could use latency-based routing. We could use weighted round robin routing to help Route 53 decide which region to route that customer request to. So I don't want to say easily, but with a little additional work, we could deploy this across multiple regions. The other thing that I want to keep in mind or point out again is the idea of the static and dynamic content all flowing through CloudFront. It's not necessarily the way that you have, the absolute only way you can do this. You can actually create a distribution that looks at only the static content and have all of the dynamic content flow through your load balancer. It takes a little more work to set that up. So sometimes it's much more convenient just to direct everything through CloudFront and then use URL patterns to help CloudFront determine where to route that request for information that's dynamic or something that's not in its cache. Now, the one thing that I would point out compared to our previous version, our previous reference architecture, is that this is a much more complete solution in the fact that actually complete isn't a fair word. It's a more flexible solution in the fact that we do have applications running. So we can do server-side processing here. We have a more dynamic website at this point, but that comes at a cost. There's increased administration associated with this solution. In this case, I mean, we have EC2 instances that are running. So those EC2 instances mean, if you think to the shared responsibility model I mentioned earlier, as customers, we're responsible for the operating system, the applications that run on that operating system, in this case, a web server or any other supporting applications. So that means patching of the OS and the application, maintenance of the application components on that EC2 instance. Those are all our responsibilities. So that's what I mean when I say increased administration. The one other thing that I would point out here is that in the majority of cases, if you were to build something like this, you should really look at an infrastructure as code solution, CloudFormation, or something like Fugue in order to help you deploy and manage this infrastructure. It reduces a lot of the administration that's associated with keeping this infrastructure up and running. So always look at how you could layer in something like an infrastructure as code solution to deploy this. If we compare costs to the previous reference architecture where we were hosting our static website, the costs to do this are more, right? As soon as we start putting in EC2 instances, we're paying by the hour. Now, if we're using auto scaling, we can reduce those costs and keep them at a minimum during times where we don't have a lot of requests, but we have we have compute infrastructure here with EC2, we have RDS infrastructure. All of those are going to contribute to the bill. If we flip back just for 1 second, I wanted to point out here that although this is a very simple solution, it also, like the last example, is able to span multiple regions. So if you require that, it's quite easy to set up. S3 has a cross-region replication feature. And to create that, what you would need to do is create a source bucket and a destination bucket. So if this was in region A as our primary region and region B as our backup, we would create a bucket in both regions, enable versioning on the buckets, and then enable cross-region replication. Versioning is required in order to do cross-region replication. If you do this, remember that it's going to increase your storage costs as well as potentially your data transfer costs because you're going between regions. So you'd have to do some cost comparison and make sure that your application or your website does actually require cross-region replication or multi-region deployment before making these decisions, but it is possible. And finally, we have a serverless solution. So this is a very basic example, but it shows how you can combine, I think, the best of the static website option, version one, or option number 1, with this idea of being able to serve dynamic content to your customers. This is actually how, if you go to CuriousOrbit.com, how Curious Orbit is hosted. It's a static website with the API gateway integrated into the static website to handle any sort of dynamic requests. So again, it looks very similar in the fact that we have Route 53 and CloudFront in the front of this solution. Again, Route 53 for DNS, CloudFront for caching. Depending, again, on the requests that are made to our infrastructure, we push those requests to an S3 bucket for dynamic content. And then if somebody's making we push the request to an S3 bucket for static content. And depending on the actions that that customer is performing on the website, we could redirect them to the API gateway in order to handle dynamic requests. So think of the API gateway as the front door to your application. And in this reference architecture, I've simplified it greatly in the fact that I'm showing integration with a single Lambda function. In this example, Lambda is integrating with a DynamoDB table. Just know that with Lambda, we can integrate it with potentially any service on the Amazon platform, as well as services that are external to AWS. And I'll give you an example of that. On my website, depending on actions that you're performing, I may create a record for that interaction in my CRM solution. I use Base CRM, and it has a fully featured API. What I'm able to do is, depending on actions that you perform, I can use a Lambda function to interact with the Base CRM product via its API and create information, lead records, contact records, action records, things like that. So I'm showing a very basic deployment here, but just know that you can extend this functionality out quite significantly. So requests come to our application. They're routed through Route 53 again to do name resolution. And then CloudFront, using URL patterns, again, determines where to route that request. API Gateway, fully managed service, which makes it extremely cost effective. It has inherently HA built in. It has advanced features like caching. So if you have a very active API that is calling the same information all the time, we can offload that work again from the back-end instances to help us not only protect those instances or that infrastructure from excessive requests, but also potentially lower the overall cost associated with running the infrastructure by deploying smaller solutions. And like I said, there is direct integration between the API Gateway and Lambda. So Lambda, if you're not familiar, is the serverless solution on the Amazon platform. Again, fully managed solution. So all of the HA, all of the durability and the redundancy is handled on our behalf by Amazon. You're able instead to focus on the functions or the logic, the programming logic that you need in order to fill those requests. You can cut and paste that code. You can reference that code stored in an S3 bucket, and Lambda will almost immediately invoke those functions based on, in this example, calls that are being routed through the API gateway. Another thing that I'll just point out here, we're going to talk about cost here in a minute. If you're not familiar, Amazon has what they call the free tier. And for new accounts, you get access to the free tier for 12 months for different services up to a certain amount of consumption per month. What's fantastic about Lambda is Lambda has what's called a perpetual or a never-ending free tier. That means we're able to make a certain number of requests and consume a certain amount of resources in the Lambda service every month in perpetuity, free of charge. Now, I would always recommend that, number one, you look at the free tier page and understand what exactly the limitations are every month for your first 12 months. And then also make sure you understand the costs associated with the services. So my recollection of the Lambda service is I can make 1 million requests and use 400,000 gigabit seconds of processing time per month in perpetuity, free of charge. So when you compare this architecture to the previous architecture, I think there's a bunch of additional benefits here outside of cost. We should be able to greatly reduce the overall cost of hosting a website on the Amazon platform by building out a serverless infrastructure like that we have in this reference architecture. And the reason that you're able to do that is when you look at your bill, and when I help customers with cost optimization, there are 3 main areas that contribute, I would say, anywhere from 75 to 95% of the cost associated with your infrastructure. That's compute, storage, and database. The only storage that we're using here is in S3. And S3 is object-based storage, and it's much more cost-effective than elastic block storage. Again, depending on the region, and always check the pricing, S3 starts at about 3 cents per gig per month. When we compare that to elastic block storage, which we would have to use in the previous example for our EC2 instances, that starts at around 10 cents per gig per month. The other difference between those two services is that elastic block storage, or EBS, you pay for provisioned space. So that means if you provision, I'll just make a number up, 10 gigs of space for your website, you pay for 10 gigs, regardless of you using 1 gig or 9 gigs of that space. S3, much more cost effective per gig, but also it's a utility model, which means we don't have to provision any space. The buckets that we create, we only pay for the storage that we use every month. So when you compare this reference architecture to the previous one, we should be able to greatly reduce the costs associated with running our website in a serverless environment. And I would prefer this solution over the first static website because I have a more flexible solution here. Most websites, modern websites, do have some sort of dynamic content. Could be as simple as passing form information back and forth, filling out contact information, things like that. We aren't able to do that in the first reference architecture. We need a server to process those requests on our behalf when somebody fills out a form, as an example. The API gateway becomes our server to handle those requests. And in this example, I can integrate the API gateway with a Lambda function to store customer information, maybe from a form they've filled out or request they've made, in a DynamoDB table, as an example. There is absolutely, or I shouldn't say absolutely, there is very little administration required when we look at this solution as compared to the previous solution. There are infrastructure as a service offerings here, there's platform as a service offerings. All of those take some administration. We've offloaded all of that additional work to Amazon here, so we can greatly reduce the cost as well as offload much of the administration, obviously not all of it, but much of the administration to Amazon. The other thing that's very important to point out here is availability and scalability. All of that we're using managed services. So all of the HA and scalability is managed on our behalf by Amazon. The the API gateway will scale based on the number of requests coming through that front door to your application. Lambda functions inherently will scale based on the requests that are made. The only thing that won't natively scale here is DynamoDB in this example. Okay, but there are open source products out there that you could integrate with your DynamoDB table to use CloudWatch to understand the actual usage of the table and adjust the write capacity and read capacity units, or you could use another service here to pull the data and be able to lower the administration again. But when we compare this reference architecture to the previous reference architecture, the overall administration is much, much lower. So lower administration, high availability, scalability, natively supported by the managed services, and we can serve static dynamic content at a much lower price. So I just want to reiterate through the three solutions. The first solution that we have is a static website. Very easy to get started, very cost effective, limited in the fact that you cannot, it's only static. You can't serve any dynamic content here. There is no server involved. And quite easy, I would say, to replicate across region if you need it. The next version here, highly available, scalable deployment, allows us to serve both static as well as dynamic content. It's going to cost us more, and we have to be involved in the administration of this infrastructure in a much more deep way than the previous example. We've got infrastructure as a service offerings here, so we need to manage applications as well as operating systems. My preferred method is method number 3. I have a basic way that I engage with customers, whether it's for training engagements or professional services, deployment services. Serverless first. That's where we'll start. And when I think about serverless, I think of much more than just Lambda. We've got the API gateway here. We've got S3. We've got CloudFront. Obviously, there's infrastructure that's being used to deliver these services, but we don't have to worry about the sizing of that infrastructure or the maintenance of that infrastructure. It's serverless. Okay. This would be my option 1. Option 2 would be to use platform as a service, sorry. And then finally to go to infrastructure as a service. So that's kind of the way that I approach it. You can see in this solution here, reduced administration, inherently HA and scalable at a much reduced price. And now we're able to serve both static and dynamic content. So that wraps up to today's webinar. I just wanted to open it up to anybody to ask questions. And I also wanted to point out that I publish a weekly newsletter Sunday mornings, usually around 9 a.m. Eastern. And I publish content that is not on the blog at this point. So it gives you an opportunity to see that content before it's published. We also occasionally put industry news around AWS if there's a big announcement. So you can follow this link here if you'd like to subscribe. And like I said, once a week, you'll get an email. Outside of that, I'd like to open it up for any questions. We have a quiet audience today. It's the dangers of hosting a Friday afternoon webinar in July. Okay, well, I want to thank everybody again for taking the time to join me today. I really appreciate finding some time in your very busy schedule on a Friday afternoon to join me and learn a little bit more about Amazon Web Services. If you'd like to contact me to talk about something else, please feel free. You can find contact information on CuriousOrbit.com. You can look us up on LinkedIn if you'd like to reach out that way. With that, I want to say thank you very much, and I hope everybody enjoys the rest of their afternoon. Thanks, everybody.